Okay, so this is the Leslie cube experiment. So for this question, figure 1 shows the electromagnetic spectrum. So radio wave has the highest wavelength, and then gamma rays has the lowest wavelength, but gamma rays has highest frequency, radio wave has the lowest frequency. In terms of energy as well, gamma rays have highest energy and radio waves have lowest energy. Okay, which statement is correct for the direction of error for figure 1? The wavelength, so what is happening in this direction, the frequency is increasing and energy is also increasing. So wavelength decreases and wave speed in the air increases. That is not true. Wavelength is decreasing, that's true, but speed of all the electromagnetic waves are same. That is 3 times 0 times 10 to the 8 meters per second. That is the speed of light. So all of these electromagnetic spectrum have the same speed. However, they have different wavelength and frequency and energy they carry. So the frequency increases, wavelength increases. That's wrong. Frequency increases, true. Wavelength decreases. Frequency increases, wave speed in the air stays the same. Yeah, that's true, and that is also true. So that is the same right answer. So the speed doesn't change, it stays the same, and frequency also increases and energy also increases. Explain how the property of X-rays make them suitable for medical imaging in the bone. So they goes through. So X-rays penetrate through soft tissues, and then X-rays are absorbed by the bone. So hence you can use that for medical imaging. Okay. A student investigated the infrared radiation emitted from side of a hollow metal tube. So this is a Leslie cube. So the side of the cube are different colors or textures. So one is shiny silver surface, matte black surface, matte white surface, and shiny black surface. They have a ruler, they have an infrared detector, and they have a kettle filled with hot water as well. So boiling water was poured onto the cube. The amount of infrared radiation emitted from each vertical surface was then measured. So boiling water is a hazard in this investigation, such as to how the risk of harm could be reduced in this investigation. So what you can do, complete the investigation standing up. In case anyone spilled water, you can jump around and you can move away from the situation quickly. So complete the practical standing up. So that is one of the reasons why we ask you to stand up throughout any practical. And you can use slightly cooler water. You don't have to use the proper boiling water, so you could use slightly cooler water than proper boiling water. And you can use, make sure to not touch the metal cube. So do not touch the metal cube, otherwise you're going to burn your skin. So what is the control variable in this investigation? So the distance you place your infrared radiation detector from each surfaces. So the distance between the surface and the infrared detector. Another thing in this experiment, in this question they didn't ask, but how would you prevent the heat loss from conduction? So that's why we use a heat-proof mat here that prevents thermal energy loss loss through conduction, and we do have a lid or a bunk that stop thermal energy lost by convection current. Okay, so heat can be lost by convection, conduction, and radiation. So what we are interested is in radiation. So we are controlling this by having a heat proof mat at the bottom and having a lid to stop the thermal energy loss through convection. Okay, so the following table shows the result. Type of surfaces: matte black, matte white, shiny black, shiny silver, and these are the temperatures. So the 4 temperatures value in the table cannot be used to show that the infrared detector gives precise reading. So give a reason why. So why can't we Okay, 4 temperature values of the cannot be used to so the infrared detector gives precise reading. So the reason why they haven't repeated this experiment, that's why. So the temperature, so the reason why the table cannot be used to show the infrared detector gives a precise reading is because the measurements have not been repeated. Okay. Right, the student looked at the data in the table above and concluded the black surface always emits the more infrared radiation than the white surface. Explain how using an infrared detector with a resolution of 1 degree Celsius would have affected the student conclusion. So if it is 1 degree resolution, this one, the current one they used is 0.1 degree Celsius resolution. So between shiny black and matte black, they are all so it is because it has a higher resolution, you can find out the matte black and shiny black has this reading. But if you use 1 degree Celsius resolution, you would both will be 66 degree and 66 degree. That is the reason why if we use a lower resolution, they wouldn't be able to get this conclusion. So they could not conclude that black surface always emit more than white surface. So a matte white surface appears to emit the same amount as the shiny black. So both reading would be 66 degree. So that's what you have to say, okay? Right, so albedo is a measurement of the amount of solar radiation reflected by an object compared to the total solar radiation incident on an object. The perfect reflector has an albedo value of 1 and perfect absorber of an albedo value is 0. What is the albedo value of perfect black body? that will be 0.0. So perfect black body is, so perfect absorber. So perfect black body is like example our sun. It doesn't reflect any, if you shine light upon it or heat upon it, it absorbs 100% of the radiation. So perfect absorber, so it absorbs 100%, okay, of radiation. So if they ask you what is a perfect black body, an object that absorbs 100% of the radiation incident upon it. So figure 3 shows 2 points A and B above the Earth's surface. So A and B. The average albedo value of Earth's surface is 0.3, and albedo value of thick cloud varies between 0.6 and 0.9. At night, the air at A cools faster than air at B. Explain why. So, the reason why it is because the albedo value is amount of absorption. So if it is 0, that means it's absorb 100% of it. If it is 1, it is reflecting 100% of it. So what's going to happen? This one, A, all the infrared radiation can be emitted out of it, so it can keep on cooling down. But here, what's going to happen? The cloud is going to only absorb how many? 30% of it, and then rest of it is going to reflect it back onto this. So that is why on a warm day, if you have a lot of cloud at night times, it's really hard for you to sleep, because that is going to be warmer day. So if it is a clear sky, a clear day, in the night time it's going to be cooler. Okay, so that is what they are asking. So at night, more radiation is emitted from the Earth than absorbed from space. Cloud reflect radiation. At A large proportion of radiation will be emitted into the space. Okay, so at night time, more radiation is emitted. From the Earth's surface than absorbed from space. So cloud reflect the radiation. And then at a large